Okay, so there are some terms associated with ellipse, just like with any of the other shapes that we have. If you have x squared over a squared plus y squared over b squared, then the vertices are plus minus 0 and 0 plus minus b. What this means is those are the points. You have a0, negative a0, you have 0b, and you have negative or 0 negative b. So it's symmetric in that sense. The major axis, that's the one that goes through, let's call it the more elongated part of the ellipse. So in this case it's horizontal and the length is 2a. And the minor axis is vertical and it's 2b. And the focus happens to be at the point plus minus c, where what is this relation? Remember, in our derivation we said b squared is a squared minus c squared. So another way of saying that is c squared is a squared minus b squared. So to find the focus, given equation in this form, you just find c squared, or you solve this for c, and the two plus minus values give you the focus. Now if I switch the a and the b, then what this means is now my ellipse is elongated in that sense. So the vertices now, the x part is b0, negative b0, 0a, and 0 negative a. So the vertices become plus minus b0 and 0 plus minus a. Now the major axis, the elongated part is vertical, so the major axis is y-axis and the length is 2a. The minor axis now is x-axis and the length is 2b. The focus is still plus minus is 0 and then plus minus c, because now the focus or the foci lie on the y-axis. So you have to respect the coordinate system and write it as 0 comma plus minus c instead of plus minus c comma 0. And that's the sketch. Let's look at an example. Find the foci, vertices, length of major minor axis for this function. So first of all, let's keep using green. This is of the form x squared over a squared plus y squared over b squared equals 1, where a is greater than b is greater than 0. Okay. What is a? A is plus minus 2. B is, 3. B is plus minus 2. So we know that this sort of, that's what it is. So this is 3, 0, negative 3, 0, 0, 2, 0, negative 2. Now c squared is a squared minus b squared, 9 minus 4, 5. So c is plus minus root 5, which means the foci are at 0 root 5 and 0 negative root 5. The length of major axis, that's over here, is 2a, so it's 6. The length of minor axis, 2b, is vertical, is 4. That's pretty much what it's asking, and you already found the vertices, plus minus 3, 0, and 0, plus minus 2. Again, now we just look at some examples where you may be given information in different forms and you still have to end up with the equation. First one, find the equation of ellipse with vertices plus minus 4, 0 and foci plus minus 2, 0. Okay, so first of all, just by looking at it, if my focus is on here, that's x-axis, right? So it's gonna be that form. So this is plus, this is 2, 0, this is negative 2, 0. So c c squared is 4. And then these vertices are given to me as 4, 0, negative 4, 0. So a squared is 16. So then I know b squared, what is that from our definition, is a squared minus c squared is 12. So my equation is x squared over a squared plus y squared over b squared equals 12. Sorry, equals 1. So same story as parabola, where different values give me, or there can be multiple ways in which you convey the information about how to find the equation. Now, just as in parabola, where we looked at the width of parabola as another special property or characteristic, for an ellipse, there is a term called eccentricity. So for any of these ellipse, the eccentricity given by E, and is defined as the ratio of C to A. Okay, and remember, C squared is A squared minus B squared, so C is square root of A squared minus B squared. Now, question is, what is the eccentricity of a circle? So what really is a circle? In the case of a circle, where's my focus? My focus is at 0. Yeah. So C is 0. So if C is 0, E is 0. So E equals 0 means that it's a circle. So that gives you an idea that, so for example here, what happens when E is 1? Yeah. Let's see. If E is 1, then C equals A, or C squared equals A squared. Right, but if C squared equals A squared, then the problem is B becomes 0. So in that case, what happens is you just get a line. So between, as E goes from 0 to 1, it sort of measures the ellipseness of the ellipse. If there is no eccentricity, if it's 0, then it's not an ellipse, it's a circle. If this eccentricity is 1, then it's weird, it's just a line. And between those values, you get different forms of stretching. Yeah. So 0, and as you keep increasing, it becomes more and more elongated. So that's what goes in this section here. So again, that becomes another way of phrasing information about ellipses. Find the equation of ellipse with a foci 0, plus minus 8, and eccentricity E equals 4 over 5. So eccentricity is C over A. Foci is on y-axis, so you expect something like that. And what is foci? Foci gives you the value of C. Right? So C is 8, plus minus 8. So that gives you A is 5C over 4, which is 5 over 4 plus minus 8 plus minus 10. Then B squared, by definition, is A squared minus C squared. So it's 100 minus 64 is 36. So B is plus minus 6. So the equation is x squared over, and here you have to be careful. The focus is on the y-axis, which means the major axis is y. So it's x squared over b squared plus y squared over the larger number. 100 equals 1. Because it's elongated along the y-axis, the larger value is under y squared, because these points are now 0, 10 and 0, negative 10, whereas these points are 6, 0 and negative 6, 0. So it's narrower on the x-axis and wider on the y-axis. Okay, so last, just a fun fact about ellipse. because for parabola we consider light reflection and how they meet at the focus. For ellipse too, because we are using the word focus, there must be some relation, and the relationship is that if you place a beam of light here, all its reflections are gonna go through f2. So from one focus, if you shine a light, it's gonna reflect and sort of meet over here. Similarly, if you anything going out of f2 is gonna end up at f1. And this design principle is used in whispering galleries. A whispering gallery, what it is it's this huge place. There might be walls, and there's a person here, there's a person far away, and there's no way you can hear them because they're too far. But it's designed in such a way that it has this elliptical structure, so that if this person just whispers over here and you're standing at the appropriate place, you can hear them. But if you're slightly away, you cannot hear them, right? And it works because as long as the two of you are on the focus, so you design this in such a way this person knows where one of the focuses and you know where one of the other foci is. You go stand there, if this person whispers, you can hear. Anyone near you not on the foci is not gonna hear. So that's a cool application. Some old structures have these whispering galleries for I guess for trading secrets and stuff without anybody else being able to listen over. And the reason it works is because of this sort of reflective, this symmetry over here. And why it works is like light and sound. Light, for example, takes the shortest path, and the shortest path here is going through the two foci. Okay, that's about it for ellipse. The next video will be about the last shape, which is hyperbola.